So, as I said, tonight I would like to talk about MobX and the friends, right? My name is Andrei Pfeiffer. I work as a co-designer here at Espresso, and since 2013 I'm one of the co-organizers of this meetup called Tim.js. Well, I'm not gonna start about to talk what is MobX. I mean, not. Let me rephrase that. So MobX is a state management library, right? We use it to manage our application state. Now, I'm not going to talk about what is or why would you use a tool or a library such as to manage your state, your application state. So I'm just going to go through the features that a state management library should do. So it provides a store where it stores the shared state of the application. It provides some connectors for the components to connect to that store and retrieve the data. It defines some actions so the components can update the shared store, right? And then it should update all the components that are interested in receiving those updates. And it should also handle network requests because the components shouldn't know where the data is coming from. It's coming from the store, is it coming from the network, so they shouldn't know. So all the logic that happens regarding the fetching of data should be outside the component, should be somewhere else. Usually the stores handles this kind of stuff. So we have a lot of options to choose. So one of them is MobX, not so popular, which I'm gonna talk about tonight. The popular one is, of course, Redux. Probably most of you have heard and maybe even used Redux. So I will use Redux as a comparison for MobX, but in a friendly way, not in a non-friendly way. Other options are Unstated. Unstated is a rather new solution, also from Facebook, which was launched somewhere at the end of last year. It's more simple than Redux. I'm not going to talk about it tonight, but if you want to see how it how it is used, I have some code samples and I can show you at the end.
Does it fit in a Lightning?
Yeah, I think so, maybe. Okay. By the way, it's only. I mean, it can be used only in React applications, so it's not like framework agnostic. Another solution is Vuex, which is the dedicated solution for Vue.js applications. It's very similar to MobX, but also I'm not going to talk about tonight because it's only restricted to Vue.js applications. Then we have MST, which is MobX State Tree. This is a library that is built on top MobX, and what it basically does, it brings some Redux functionality into Redux. One of the main functionalities that it brings is one very cool feature that everybody is so so happy about, but nobody uses: time traveling. And today at lunch, I just discovered this new library called Govern. It is very similar to Unstated, but I'm not going to talk about it because it's like really brand new. But it was yeah, funny to find out just today that another library was released. Okay, so some things in common for MobX and Redux. They are both framework agnostic, so you can use both of them in React applications or Angular applications. They first started in 2015, so they are equally mature or equally immature, how you want to see it. And as versioning goes, MobX version 5 was just released like a few days ago. So basically, they more or less have the same version. So more or less the same progression in time. Okay, let's talk about MobX. First of all, how many of you have heard of MobX? Pretty many. And how many have used? Only a few. Only one, two. Okay, 1, 2. Cool. I'm gonna go very briefly through how to use at a very high level. What are the key components of MobX? First of all, there is a provider, just like you have in Redux, a provider that is basically you wrap usually your root component, you wrap it in a provider in order to be able to pass the store to all the connected components. So just import it from MobX, and you pass an object containing all the stores that that you have in your application. This is one big difference between MobX and Redux. Redux only uses one store, MobX uses multiple stores. What does a store look like? Well, it's just a simple JavaScript class. Actually, it's an instance of a JavaScript class, so a store is basically a singleton, only one instance. What you can define in a store? Well, you can define observables. Observables are reactive properties, and you use the @observable decorator. By the way, this is just a syntax sugar. You are not enforced to use decorators, but the syntax is much nicer and succinct. So these observables are just reactive properties. MobX adds some getters and setters to these properties internally in order to track the changes that happens through them. Since we have observables, they can be observed by some observers. So our observers are the components. In our case, the React components. So observer is imported from MobX React, which is the glue between MobX and React. And there is also a MobX NG, which is the glue between MobX and Angular, right? And you basically decorate your components using this @observer decorator. This is similar to the connect method in Redux. You connect your component to the store. Then you have to inject some stores, because probably the components are not interested in all the stores that are available in your application. You inject the stores that the component is interested in. And basically, if you inject the counter store, then that store is available on the props, on the component, and you can access, you can simply access your properties using this .props.counter, which is the store, .count, which is the observable property. This is similar to using map state to props in Redux, because you don't need all the states usually in a component. You are just interested in some part of the entire state. How do you edit or how do you modify the store? Well, you define some actions inside your store. You annotate them with the action decorator, and you just modify, like you mutate, actually mutate the value inside your store. In Redux, you would have to use like define an action type, create an action creator, and then implement a reducer in order to basically to get the same effect. So a lot more orchestration is required. How do you call an action? It's just available on the store. You just call it like any other method. This .props, .counter, the name of the method, and you just pass the value. In Redux, you would have to map your dispatch property to the props in order to make them available in your component, and then bind your action creators, and then dispatch some action that will get to the reducers. So again, a bit more orchestration. In MobX, everything is really more direct. In Redux, is more indirect. So you have to follow some specific path, and we'll see later this path, which this path is. So until now, all the features are pretty much the same. They are just accomplished using different methods. But MobX has some additional features. One of them is you can define computed properties. So computed properties are you can use actual properties in your store and then get derived data based on them. So you just define a getter property, and you annotate it with computed. And here we are using discount and just put some string in front of it. And every time this the observable property changes, only then the computed property will change as well, and will notify all the components that use that property. Yes, Cassian.
I'm curious about the get syntax. Do you need to use get, or?
Yes, because it's a getter, so it's a property.
Okay.
It's not a method. So this is a ES syntax for getters.
I know.
Yeah.
I was just curious whether muted means that
Because it's not a function.
Okay.
Yeah, that's why basically it's a property. So it just.
I have a question
Yeah.
regarding, can you do funky stuff with count, like on the previous slide? If you start to do object assign and put properties on, if it would have been an object, and you start in the observer, you start to do object assign, or if it's an array, if you start doing push inside it, everything works?
Regarding objects, there are some limitations which you have to understand in order to use them in MobX. So by default, it will only track the properties that are available at when it's compiled at definition time. Yeah, exactly. If you add another property, it won't be tracked.
Or if you delete tracked properties?
Yeah, I don't think. I have no idea exactly.
So then basically don't do funky stuff with it. And
Don't do funky stuff. Yeah. But there are ways around that. So not to do funky stuff.
Map state to props.
Just a question here. Are the stores immutable here, or
No, the stores are mutable. Are mutable. I will.
thought because of the
Yeah. Are mutable. So in order to achieve these computed properties in Redux, you probably require a library like reselect, which implements basically the same thing. Sorry?
You just do map state to props.
Hmm?
You just do map state to props.
And if you need the same thing in two different components,
You map state to props, you create a
and you
generic
implement.
function, call it in two places. Why not?
put it in a util.js file.
Yeah, exactly. Precisely. Oh, come on. Yeah, you
Yeah.
make a function and call it in two places.
Yeah, okay. It's a boilerplate.
First duplicate the code in three
It's a
places,
boilerplate.
and then you make
Late-ish.
Okay, debatable.
Yeah.
But yeah, you have to put some extra buttons. I mean, that's why the library was created, and also reselect and MobX. When you use it's a different method called transformers. So basically, these are only properties that I spoke here. So we cannot pass a parameter to this thing because it's a property, right? But you can also define like methods which receive a parameter in order to compute some data based on some input, and those are automatically memoized internally. So you get the benefit of this as well from reselect and from MobX.
Okay, sure, why not?
Okay, as you said, Korchi, right? Mutable state. So it's more simple in JavaScript, in MobX. JavaScript is not created around immutable data structures. So in MobX, you basically mutate the state directly. So you use all the JavaScript methods that you know to modify or to parse arrays or JavaScript objects. You don't need to return new references every time you mutate something. If Redux requires immutability, you might want to use some immutable library in order to help you with that. About data, or a consequence of the previous part is that MobX doesn't require data to be normalized. So it can work very well with very deeply and very complex data structures. A normalized data structure, I mean, this is a denormalized one, and if you want to go to a normalized version of this data, basically every array you would have to turn into an object. The property or the identifier or some unique identifier of those elements have to be put as the property of that item, and every deeply nested array would have to be pushed to the top level of this data structure. Will look something like this. So as you can see, users is not an array anymore. It's an object, and the property is the ID, basically to uniquely identify those items. And the skills array only contains the identifiers which and the data is defined at the same level as users. Adi also discussed about this last time when he talked about NGRX, right? And it's way easier, yes. But if you have really deeply nested data structures, then it's really a pain in the ass to work with those data. There's also a library for this. It's called Normalizer, which does this work for you automatically. And also one common thing you might do is fetch some data, defining.
I got lost in one, sorry. So for MobX, do you have to do that? You don't have to do that?
No, I mean MobX you can work with any type of data because it just it's easy to parse and to work with deeply nested data structures.
But as long as they don't change the structure in the meantime, right? This is what you said previously.
The structure, yes, the structure.
But the reason
So
why
when you first set like replay the state with a specific structure, then that's good.
Sorry?
So you cannot add anything to the state afterwards after you define it.
Oh yeah, you can. I mean, there are ways to do that.
Okay.
Just that if you define an object and you just add not a new property, just like that, it won't. You won't track that.
Showed with the members, find, set stuff. If you do that, you can mutate it, right? Like you showed on 2 slides before.
Yeah, but I didn't add their property.
You put something.
It's supposed to be
Ah.
observed.
I just did.
Okay, but if you would have added an extra key, it would have worked, right?
Yeah, exactly. Yeah, but again, there are ways around that, so you can achieve this as well.
But the reason you would do in Redux the normalizations are still valid for MobX. Why you would do them?
You could do that if you want to,
Oh,
but only just a matter of preference. In the Redux, like it's really complicated to have deeply nested data structures and to work with those.
because of the updating mechanism.
Yeah, the updating. Yeah.
Okay.
I mean, from my own experience, it's really a pain in the ass. I don't know what's your experience
Well,
with this?
for keeping in sync stuff, and for that, I think the reasons are you're gonna do it in both places to be able to easily keep in sync various stuff.
Yeah, the reason to normalize data is, for example, if I have skill 11 referenced in 2 places, if it's immutable, then I'm probably going to end up like copying, right? The data structure to show it in 2 places. And then when I update it, I want it to update in 2 places. But I mean, there's still a valid case for normalization, even in the case of mutation, because if this comes from a JSON service, then they're not referenced. They're still different objects, so you're still.
Of course, it's a valid case. Yeah.
You're still better off normalizing.
Yeah.
Yeah, or at least deduplicating if you can do that.
Yeah, if you use if you have really deeply, yeah,
It's
you
still
could.
valid case in
It's
both
valid. Yeah, of
scenarios.
course, it's very valid. Yeah, I'm just saying in the case of Redux, I think you
have more reasons.
You have more reasons to do it. Yeah,
Yeah, true.
a lot more reasons.
But one. It is double the amount of reasons. True.
Okay, async actions. In MobX, it's really easy to do fetch and async calls. You just use async method and functions, and if you modify the state of the store, then you have to wrap this kind of stuff. I mean, the code that modifies the action, you have to wrap it in a running action something. There are other ways to do this as well. There are, I think, 3 or 4 different methods to handle this async stuff. Basically, this is required in order to have this working. So running action basically binds this keyword to the correct context within the class. In the case of Redux, of course, you are required a separate library, Redux Thunk, Redux Saga, or Redux Observable. One of them, it's your call. So only feature-wise, MobX equals Redux plus all this kind of stuff. Read, select, normalizer, immutable, JS, and tons. Okay, let's talk about data flow. So in the case of Redux, we have a component tree and we have a single store. Components are connected to the store, they get data from the store, they call some actions, the action dispatch to the reducers do some work and they update the store. Also the actions can read data from the store, they can call maybe other actions, dispatch some to other reducers. So, but the way the data flows is like really in a circle, right? So it's pretty easy to understand how the data flows through your application, but it has to travel like a lot from the component to get another update to the component. Like it has to travel through all these kind of stuff. In the case of MobX, like you have the same components, and as I said, you have multiple stores. Now the stores have collocated actions. So you have in the same file, you have the data and the actions that modify that data. So usually components are connected to multiple stores, right? They read the data from the stores. They dispatch some actions which modify the stores, and those actions could call other actions and could get data from other stores. So everything more or less look probably like this. So it's more entangled, right? Because everything is connected directly to anything else. Not like in the case of Redux, where everything has to follow a certain path, right? This is probably one of the key, or another key difference between these two approaches. Now I have exaggerated a bit with the lines here, but just to make the point of MobX. And when you look at these two diagrams, it's like one-way streets versus two-way streets. Now, probably most of you guys are drivers here. Now, I recall in Timișoara a long time ago when we didn't have the one-way streets, only the two ways, and all the drivers complain like, "What the hell don't we have a one-way streets? Because everything is so difficult to get around. You have to wait a lot for the other direction to make a left." And then at some point, a lot of streets started to become one-way streets. A lot of them. And the same drivers, I heard, now they are making all the streets one way. Because to get from this place to this place, I have to travel all around, and it's so difficult to get from short distances. So either way, you get to a point where any approach becomes a bit troublesome for you, right? There is no definite best way to do things. So this is like the trade-off that you have to I don't know, to take into consideration in regard to the architecture of your application.
Great trade-off. I mean, one way is the two-way street thing is essentially Angular 1 with all of the issues that one had.
Yeah.
And the other way is the way we've all kind of agreed is better.
Well, actually, to be fair, Angular 1 has the right side overlapping with the left side, so it's everything and like that.
Yeah. Okay, sorry, so it's not as bad as that.
Yes.
But it's comparable.
Okay. One thing about complexity versus difficulty. Like when you say that something is complex, we refer to how many different things and how to put it. So simple things are you don't require a lot of knowledge to understand them. Complex things require some considerable amount of knowledge in order to understand these. In regard to difficulty, when we refer to the effort that you need to make in order to get some stuff done, right? So it's either easy or hard to do something. Now, in the case of complexity, Redux is really simple because there is a lot of people say that you can actually read the source code. It's very short and it's very you don't need to know a lot of stuff previously in order to understand what Redux is, how Redux works internally, right? Because it just takes some objects and mutates, creates new references. So it's very, very simple the way it works internally. On the other hand, it doesn't do a lot of work for you, right? you have to put a lot of extra effort in order to use it, because it doesn't have a lot of features. So you have to bring all these external libraries, or create your own libraries if you want to, and so you have to put a lot more effort into using it. And a lot of people also complain about this, the boilerplate, and the thing that you actually have to put a lot of extra effort in order to write, in order to use it. Now, MobX, on the other hand, is complex because you have to understand the reactivity, and it does a lot of magic, so it's more difficult to understand how it works internally, right? On the other hand, it's easy to use because it does a lot of extra work for you out of the box. You don't have to care about a lot of stuff, because the library does the hard labor. Now, I'm gonna do a quick performance demo. Open in a new tab. So I have a really small application here. This is, by the way, this is the production build. So it's an application that it's a counter of counters. So you can make many counters, and when you click on them, updates the counter. Okay, and I have a +1 all here as well. Okay, so in regard to performance, like you get into performance problems when you have a lot of stuff, but not only when you have a lot of stuff, but when you have a lot of stuff and you do something continuously, right? In the case of, for instance, when you scroll a page or something, or when you do animations, that's when you need to update very frequently stuff. So I implemented this continuous update, and whenever I move my mouse, the counter updates, in order to test the limits of these awesome applications. So let's actually measure the performance here. So I'm going to put 10 levels deep. There are a lot of components, and I'm going to record this. I'm going to click once here, once here, once here. I'm going to do +1 to all 3 times. And then I'm going to do some continuous updates. And if you see, like, this is really lagging behind, right? I'm going to stop this. And we're going to look a bit at the results. So we are interested basically in this yellow things here, because the yellow thing is the scripting part of the process. So here I have 3 peaks where I press the individual counters, right? 3 peaks, like 80, 60 something milliseconds. Here I have the peaks where I pressed +1 all, right? And here I have the continuous update. So around 500 milliseconds per this unit of measurement, right? The important thing to note here is, oh no, I'm going to talk about this later. So right now in this version, all my components are connected to the store, to the Redux store. Now this is a anti-pattern in Redux, because Redux says that it's better to have fewer at few components as you can connected to the store, right? Not all the components. So I made another version of this with only one component connected to the store, and passes down the data from the store to the components. Again, 10 levels. I'm going to start recording 3 times. Also again 3 times. I'm going to do some continuous updates. Yeah, it is much better. Yeah, definitely. So only because I had fewer connections to the store, right? Let's see the result. For like 30 milliseconds, 30, yeah, 40, 30 something, and this, yeah, it's a bit lower, right? So it's definitely better to have fewer components connected to the store. But one important thing to note here is that regardless the fact that I updated only one component or I updated all the components, like I have the same amount of effort on the engine, right? Redux doesn't do any optimization for us. It basically delegates to the underlying framework, and the framework has to do, if it does, some optimizations. In the case of React, because we use React here, like it's the developer's responsibility to do optimizations and basically to implement those should component update methods on the components, right? It doesn't do anything out of the box. Now
You
let's
can take the method from the.
sorry.
There's the should component update implementation default one, and that's pretty cool. The one
On what?
for the pure components.
If you have pure components, you don't need it. It
Oh,
changes
yeah.
when it changes, when the props change, and that's it.
It does a shallow, a strict equality check.
Yes.
Yeah. But when you use objects, yeah. Okay, let's look at MobX. 10 levels deep. As you can see, the initialization time was a bit longer here. So +1, +1, +1. Yeah. It's a thing. +1, +1, +1, and continuous updates. I don't know if you see any difference, but it is very obvious.
And it's obvious why this is.
Leading
Okay.
the witness.
So here we have a totally different story. When we have individual updates, well, this one 25, whoa, a lot. Most of them should be like really low. When you updated all the components, like we get a really big difference compared to what we got previously, right? But what about here? When we do continuous updates, then it's really fast, right? It's a lot of time.
To only one.
Sorry?
Continuous updates to one.
Yeah. Continuous updates, yeah, exactly, to one element. Yeah. You can see the purple thing, which is the rendering, is much higher because it does more rendering, right? It renders this property more times. So in order to explain this, so the way I understand how these two frameworks, so these two libraries work internally, consider that you have a postal office and you have to deliver a mail to some houses on some streets, right? Well, in the case of Redux, you have only one postman. Only one postman that doesn't know whenever you call set state in your application, or whenever you update your dispatch an action to Redux and it basically triggers a change, this postman goes through all the houses and he doesn't know how many mails he has to deliver. So he goes to house number 1, checks his list, okay, you don't have any updates. Going to house number 2, the same, no updates. Goes to house number 3, okay, you have a mail. Here's your update and the component updates. And he has to do the same path over and over again, either if he has 1 mail to deliver or 1,000 mails to deliver, right? He has to travel the same distance because that's how the reconciliation algorithm in React works, because Redux doesn't do any optimization. If you want to do as a developer optimizations, then you have to put like one man in front of a street to say to the postman, this street doesn't want any updates. So it doesn't travel that street, it goes next, right? That's the component should update method that you have to implement manually in your components. Now, on the other hand, MobX has a lot of postmen. Has one postman for each house that is interested in receiving a mail. And another key difference is that the postman from MobX knows to which house to go, right? When an update is happening inside the store, it knows where house number 256 is, and it goes straight to that house and gives it the update. That's why you can do, like, it's really performant when you do small updates on large data sets compared to Redux. Now, the trade-off is that if you have a lot of postmen, then that's a lot of resources, right? So there has to be a trade-off. So if we look at the memory footprint, MobX, we should see the difference in this. "46 megabytes for MobX. Let's look at React, to Redux. Memory. Take a snapshot. 32. Now, I don't know how is that relevant, but it's definitely smaller, right? And most of this is because MobX keeps, it has a lot more closures. If you look at these types here, it has more closures. It keeps more functions in memory in order to be able to track all these dependencies between all the different components in the stores, and in order to perform like really really fast updates on small changes. Also, MobX actually implements on each component, implements his own should component update for every component. That's why it's recommended in MobX to have as many components connected to the store, because the more components you update, basically you can pinpoint better which component needs to update, and to implement better algorithm, better optimization basically for the components. So probably this is like the biggest thing between these two libraries. And if you understand these trade-offs, like probably you would be able to make some more educated decisions based on your use case. Like probably if you have I don't know, let's say an SVG with a lot of elements, and you have to update like only small elements but really frequently, right? Implementing this in Redux probably is gonna be less performant than using MobX. But if you would like to implement, let's say, a canvas, and during a canvas you have to rewrite all the canvas every time, right? Probably MobX is not the best idea to use here, because the larger the canvas, the less the performant is going to be.
Can you go back to the performance on both?
Yeah.
So wait. How much is rendering? This is the Redux one with few connections, so it's 47 milliseconds.
Yeah.
And the other one? It's 200. Why is the rendering then so?
No. This one is here. This one is here.
Ah, okay. So it's 40. Okay, so it's basically the same.
The rendering, yeah. Because it renders the same. I mean, the browser renders the same elements basically.
Yeah, but it depends on how many reflows and whatever. That's it.
Yeah, but it's the same. The browser does that. I mean, it's not what framework you use, because it's the browser's job to do the rendering, this rendering,
Because also it's,
and the painting.
Yeah, painting obviously.
Yeah.
Yeah, because it's scripting.
Yeah, exactly.
Yeah, I know, but still it matters. I mean, if you touch every DOM node, then it will trigger. Rendering will take longer.
Yeah, that scales. Yeah, that
Yeah,
scales.
I know.
That
That's
scales.
I thought it was like I was looking somewhere on the rule. It's a huge difference.
Mm-hmm.
That will have some implications on how MobX works. If I misunderstood.
Yeah.
But is this the same? Are we looking at the same points now? Or
Sorry?
Just look at overall times, like the whole thing.
The overall.
Yeah, it's just
That's not really fair because it depends on what you move on
Ah,
the
Yeah.
part, so it's not that relevant. It's
Yeah.
more, but the continuous part kills the.
Yeah. So. Yeah. Performance-wise, as far as I recall, is the same as MobX. It doesn't improve the performance. So it does the same because it uses MobX underneath. It's just a developer experience a bit.
Yeah, I know it brings immutability and stuff like that.
MobX state tree uses immutability, but behind the scenes. So whenever you make an update, it computes like an immutable tree, but behind the scenes, and you don't have to bother with immutability. Because I have rewritten this. I mean, the application that's here, it uses the same. Only the stores you have to change. Like all the connected components and all the way that you interact with the stores is basically the same. I mean, you don't have to change any components to Yeah. Ah, you work with MobX State 3?
No, I work with MobX and I check out MobX State
Mhm.
to see what it's all about.
It's very opinionated.
Probably,
Yeah, it's a very opinionated solution. But yeah, it had some benefits.
Have you tried set state
Sorry.
for the update?
It's a very nice
Simple
use.
set state.
Yeah, I've tried it, of course. I mean, last year I created a React Native application. It was a very simple one, like only 4 screens that moves from one to another. And I said, okay, no, no library for state management. And no, at the end I regretted it. I mean, you have to implement your own solution either way. Yeah. So yeah, there was a regret. So you need like state management in any application for any client.
And then you know, hello.
In or any demo application.
What about the new context API for lightweight stuff?
Unstated uses the unstated library, the one that it uses the context API in order to achieve this. One important thing I forgot to mention about MobX. So version 5, which was released like only a few days ago, as I said, is only supported in modern browsers that support proxies, because they moved away from getters and setters. So a lot of the code base went away, but it's not supported in older browsers like IE something 10 or I don't know if you need that. So probably you won't use version 5 of a MobX.
IP10?
Hmm?
IP10
Yeah.
or 9?
I don't even know. I'm just gonna say 10 doesn't support proxies.
That supports that 11 supports proxies.
Yes.
Me too.
11 is the last one, and I don't think it does.
5, there is somewhere. Yeah, it's in their documentation somewhere. What is the stuff? I11.
Not even 11.
Yeah.
Older environments such as IE11 we really need to update our definition of old.
But the previous version, like until 4.
Have you had a polyfill for proxies? Or is it a proxy is polyfillable or close?
Yeah, it should be, because it's a new API. It's not syntax sugar.
Yes, I know. But if it's polyfillable, I don't know. There are not data structures or.
Yeah, but I don't think we can fully polyfill that.
You can polyfill, then you can use any more.
Yeah.
Yeah, you have some limitations, like if you know the properties, when you do the proxy, then you have to, like adding properties.
But how far does the polyfill go? I mean, how far back?
No. What do you mean?
How old of a browser can you use with polyfill? Because it still requires some stuff.
So the polyfill more or less it takes your object and then you have to
You have to have reference in the browser, because otherwise.
yeah, but I don't know.
ES5 has
No, yeah, but it's only for DOM objects. You have to
getters and setters.
Or it had a little weird limitation.
Yeah, I remember too, because
It had a weird limitation. I'm not sure what it was.
I mean, basically, the thing with Angular was that you didn't have to do that, right? Because if you work on more browsers, you didn't have to do that.
Look, so the polyfill support browser implements the full ES5 spec.
That's just a
It's
version
not
now.
good enough for most pieces, but that much. Yeah. That's not.
Other questions if you have.
Performance for unstaged. How didn't run that?
That's comparable with Redux, because it doesn't do any optimization. even more simpler, as I said. You don't have to know about immutable stuff. You just have to know about React in order to use unstated. So it's more simple than that. But as far as I recall, so you get the same peaks and equally.
Yeah, same peaks and comparable and all everything else.
Yeah.
This one also doesn't favor immutability, or has no opinion on it whatsoever.
You just use a set state, like, so you need basically you need immutability because set state implies that, right? So you actually use the React ecosystem and the React way of thinking and the way of to write things in order to use unstated. It has only three type of only three main concepts, or only three concepts period, and you just wrap your components in some store containers, and it's, I can show you some code, I guess. Hmm? Yeah. Okay, MobX unstated. So you have the provider, again, the provider, just like Redux and MobX, and you wrap your root component in it, and you have a subscribe to, and then everything that is inside this subscribe to basically will receive updates from the store. You pass an array of stores, of store containers, and we're going to see in a moment what it is. It uses the render prop stuff, but here it uses the children in order to render inside whatever you pass it to. The store container. No. The store container is something that it stands the container from unstated, and here you keep the state, and you have the methods that set the state, and you just call the methods, and so.
The store container, it extends container. Okay.
Yeah, extends container. Exactly, yeah. And then in this app that is inside is the children of this subscribe component or the store container. This is a component, and it receives on the props like receive the store, because this property store here, that's how I define it here.
It's store, and that store is actually an instance of the store container.
Yeah, and if you had like another store here, foo, then you'll have another. Yeah, exactly. So it's very simple, like really, like basically the simplest of them all. And also one important thing is that you don't require like Redux Tank or that kind of shit, because you can basically use any fetch method that you know right inside here, right? You can use fetch or Axios or RxJS or sorry.
You don't necessarily need to use Spark.
Or you need to hack your way around the.
You can use a middleware.
Yeah, but that is a middleware.
Redux
Well,
Tank
yeah, but
is a middleware.
To help build action constructors, right? That create functions is a
Yeah, basically, if your action is a function, then it will call it.
Yeah, but you can
That's what front does.
you can actually create your own middleware for fetching data without.
Yeah, of course, yeah.
very it's really straightforward.
Kaufman. At the JS Heroes, Nir Kaufman had this talk, Advanced Patterns in Redux, where it shows how to write like this kind of middleware to implement your own, your own way to handle this asynchronous requests. It's also a book, I think, a presentation. It's really awesome. Yeah, so you can do it yourself as well, of course. But you have to do it. Like you cannot. There is no way around it. You have to press some buttons. Okay, if you don't have any more questions, thank you for listening. You can find me on GitHub, Twitter, and Medium. So, thank you.